Hello, and welcome to the first part of what's going to be the law of sines and law of cosines, which are two different ways that we can solve this triangle. And to solve a triangle just means to find all six parts. And I call this the triangle array. And when you're solving these triangles, be it a word problem or just a picture, it's going to be very helpful to look at in these capital letters. These are your three angles. In the lowercase letter, those would be your three sides. And to have them lined up with each other is really going to help you use law of sines or law of cosines. So every triangle, you have to be given at least three pieces of that triangle so you can solve the other three pieces. And one of those pieces always has to be a side. You could get two sides, you could get all three sides, but you always have to have at least one side to solve a triangle. All right, so angles are always easy. They are labeled with degrees. They'll be inside the triangle for the most part, unless there's a picture with an arrow showing you. They are the capital letters. So angle C is 81 degrees. Angle B is 36 degrees. And so whenever you have two angles in a triangle, you always have the third angle by just doing 180, right? 180 minus the other two will leave you the third one because they have to add up to 180. Some people like to add these two angles together first and subtract them from 180. I just do 180 minus 36 minus 81, so that's 63 degrees. If you only know one angle of a triangle, you can't just figure out the other two with a 180 rule. The sides are always based on being across from, and that's sometimes hard when the triangle gets drawn weird or it's a skinnier triangle or something like that. So side A is across from A. I like to think of it as if this if this vertex is C and then this vertex is B, well, between C and B is always the third letter, A. So between A and B, if this is A and B, that must be side C. And you can see it's across from the C. So between the A and the C, that must be side B. So you don't have to try to figure out, oh, what's across from it. Just look at the endpoints, and the third letter is always 1. So the one side we know is C, and we just don't know the other two sides. So for right now, we're just going to leave those blank. I just want you to get in the habit of setting up this triangle array. All right, so you have triangle PQR. We know that R is 88 degrees. And since you don't have either of the two angles, we can't fill these in without using one of our laws. So we're just going to stop right now with the angles, leave those. Really should have put angle marks for each one of these, but. And then the three sides. Well, 62 is between R and Q, so that must be side P. Between P and Q is side R, and then this missing side between P and R would be side Q. So R is 68, Q is 62, or P is 62. Now, these are not right triangles, so I can't use any kind of Pythagorean theorem or anything to find that third one. We're going to have to use law of sines or law of cosines to figure that out, and we'll do that starting tomorrow. Right now, just leave the rest blank because they're not labeled and we can't figure them out with anything easy. All right, so in this one, L is 133. That is an obtuse triangle. This Between M and L must be side N. Between L and N must be side M. So the longest side over there, that's a 1925. And I know the longest side of an obtuse triangle is always across from the largest angle. And we'll talk more about that. But that's all you can figure out from that picture. Then you're going to have to use law of sines or law of cosines for the rest of it. Sometimes triangles just have no angles. So we don't know A, B, or C. Leave those blank. But side A is between C and B, so that's your A. B has to be between A and C, and then C is between A and B. So A is 119. I think this is drawn a little bit weird. Looks like that's really the longest side, but we'll just say not drawn to scale, right? C is 128. Okay, so one of the things to be mindful of is in all triangles, whatever the largest side is, so if B is the largest side, then angle B has to be the largest angle. That's always true. It's a good way to check to make sure your answers make sense. Does your longest side give you your largest angle, or does your largest angle give you your longest side? And vice versa. If this is the smallest side, the 119, then angle A would be the smallest angle of the three. So it always has to line up, and the one in the middle is with the one in the middle. It's the old triangle inequality theorem. All right, so angle E, 120. Angle F is 30. So I can find D. If I know 2, I know 3. Always. 180 minus 120 is 60. Minus 30 is 30. And now this, because of the triangle inequality, your largest angle is going to give you your longest side. And then your smallest angle, well, these two are equal. So if two angles are equal, they have to give you equal sides. This is isosceles triangle. If you remember, the base angles would be the same, and then these two sides would also always be the same because these two angles are equal. So if EF, if this is D, is 33, then F has to be, without any kind of trigonometry, that has to be 33. Now, I don't know what E is until I use law of sines, but you can figure out one of them that's not marked because of the equal angles. All right, so K is 53, L is 112, and M would be 180 minus the 53 minus the 112, 180 minus 53 minus 112 is 15. So just from this, I know this is going to be my longest angle is going to be L. I know my shortest angle is going to be M because the 15, the one in the middle would be K. So the sides are going to line up the same way. 65 is between M and K, so that has to be L. So when I do use my law of sines to get the other two sides, I know that I'm going to have smaller than 65, both of them. All right, so C is 60 degrees. Don't know the other two. That 15 is between A and C, so that has to be B. And then between A and B, side C is also 15. So by that rule, two equal sides means that these two angles have to be equal. Now I know, right, two of them. And if you don't know that 180 minus 60 is 60, that is a 60, 60, 60. If all three angles are equal, then all three sides have to be equal. So I actually know all of that. And this is a equal angular triangle, or so you can call it an, I'm sorry, that's equilateral because it has three equal sides, or you can call it equiangular because it has three equal angles. Either one of those work. So if you have two 60s, got to be equiangular. All right, so sometimes you're going to have two triangles that are put together that they either share a side or they're going to share an angle or something, where if we look at triangle one is triangle PQS. P is 26 degrees. The other two are not marked, right? Now this angle up here, they don't have anything to do with each other because I don't know the size of this total angle Q. It's not a right angle, so I can't, so I'll have to try to find it later. But these two angles, this is a linear pair. They're on a straight line. So these two angles have to add up to 180. And 180 minus 84 is 96. So that's going to be a 96 on that side. The 84 is also angle S, but in the second triangle, 84. So now I can find the other one, 180 minus 96 minus 26. And this, I should not, like this Q over here is 58. I should not have done that. Those two aren't equal other than just by accident. I should have made it so they were not equal. So they don't have to be equal. So don't look at that and say, oh, those two are always, they're not. They're not always equal as an accident. But I can find angle R now, even if it wasn't labeled. So 180 minus the 58 minus the 84. So it's got to be 38. So there's all your angles of the two triangles, right? Now sides, this is a shared side. So 30 is between P and Q. 30 is the S. 27 between the P and S has to be Q. And then 22 is between Q and S, so it's P on this one. But in the other triangle, even though it's labeled, doesn't matter which side I label this line on, it's 22 either way, it's between Q and S, so it's side R. So be careful when they share a side. This and this, those are equal because they're the same side, but they have different letters. So once you find P in this triangle, you would know R in this one. Or if you find R in this triangle, then you know P in this one. So when they share a side, you can transfer them. Same thing, when they have a linear pair, once you know one side of that linear pair, you know the other side. All right, so the other side that I do know for this triangle is between S and R, so that's got to be Q for this triangle. These two Q's are not equal, right? Q for this triangle is 27, Q for this triangle is 32. So be careful about that when you're looking at two different triangles. S, I don't know, but we can find out with law of sines later. So your homework or your classwork or your assignment is to do just pretty much the same, do the same thing. Do your worksheet. Good luck. Have a great day.